Hello everyone, welcome to today's lecture. Today we will do the IUPAC nomenclature system. So you have studied about homologous series and the different functional groups. You are thorough with it, I hope so. Now the next is on page number 120, nomenclature systems of carbon compounds. Okay, so carbon compounds. To study about the naming of carbon compounds, first of all you should be knowing the series, the homologous series of alkanes. Basically the homologous series of alkanes. For this year the minimum 10 or minimum 7 is necessary. Okay, you have to learn the first 10 alkanes. Based on that the naming is done, and the prefix or suffix of the functional group, which I had discussed in the lecture in which I had taught functional groups. Now on page number 121, use your brain power question. The first one, draw the three structural formulae having molecular formula C5H12, that is pentane, which we had discussed earlier. The next one we will discuss a little bit later. First we will study about IUPAC nomenclature system. What is the full form of IUPAC? It has been given, you may underline that. International Union of Pure and Applied Chemistry. Okay. This is the name of IUPAC, full form of IUPAC. So IUPAC system is a system which is followed worldwide to give name to a particular compound to prevent confusion. Okay. So what are the rules? I have written the rules here. There are basically 3 rules. The first one is you have to draw the structural formula and count the number of carbon atoms. Okay, how many carbon atoms are there? So first what you have to do, you have to draw the structural formula, or otherwise you can do it from condensed structural formula also, but it is difficult from molecular formula. You will be given either the condensed structural formula or the structural formula. From that you have to name it, or otherwise they will give you the name. From the name you have to draw the structure. Okay, so what is the first step? The first step is draw the structural formula and count the number of carbon atoms. You have to count the number of carbon atoms. Write the name of the parent alkane. Okay, whether it is methane, ethane, propane, butane, pentane, you have to write the name of that alkane first. If there is a double bond, then convert ane to ene. Okay, in the alkene, the name of the alkane, if there is a double bond, then convert ane to ene, and if there is a triple bond, then convert ane to yne. Okay, that means if it is ethane, and if it is having a double bond, then it will be ethene or ethylene, and if it is having a triple bond, then it will be ethyne. Similarly, propane, propene, propyne. Okay, butane, butene, butyne. Okay, have you understood? So basically what you should be knowing, the number of carbon atoms, and if there is a double bond, put ene. If there is a triple bond between carbon atoms, then put yne. Okay, if there is no double bond and triple bond, there is a single bond, then put ane. Now convert. Okay, if there is a functional group, replace the last letter E in the parent alkane name with the suffix. Okay, I had given you the suffixes earlier and the prefix also. Now first you have to write the parent alkane, then you have to add the suffix removing the E. I have given the example which is there on page number 122. Okay, there is a box. The first one is CH3CH2OH. This is the condensed structural formula which has been given. How many carbon atoms? There are 2 carbon atoms. So what is the parent alkane? The parent alkane is ethane. Removing that E, you have to add the suffix of the functional group. Functional group is alcohol, so the suffix is OL, so the name becomes ethanol. Next is CH3CH2Cl. How many carbon atoms? 2. Now here the functional group is a halogen, that is chloro. So you have to add it first. It will be a prefix. So the name chloroethane. Br CH2 CH3. How many carbon atoms? 2. Which is the functional group? Br. So it is bromoethane. The parent alkane is ethane, bromoethane. Next, CH3 CH2 CHO. Here CHO is the functional group. CHO means aldehyde. How many carbon atoms? 3. So it is propane. What will be the suffix? As it is an aldehyde, the suffix will be al. So the name is propanal. Next is CH3COOH. What is the functional group? COOH. What will be the suffix? Oic acid. How many carbon atoms? 2. So what will be the parent alkane? Ethane. So to that you have to remove E and add the suffix, that is ethanoic acid. It will become ethanoic acid. CH3NH2. How many carbon atoms? 1. So the parent alkane is methane and NH2 means amine. So you have to remove this E and add amine. So it will be methanamine. CH3COCH3. Now here the functional group is CO, that is ketone. How many carbon atoms? 3. So what will be the parent alkane? Propane. Okay, you have to remove E and add the suffix. So the name will become propanon. Okay, so this is the second step. Now what is the third step? Number the carbon atoms in the chain. You have to give numbers to the carbon atoms in the chain. Assign 1 to functional group COOH and CHO. That means if there is CHO here there is CHO and here there is COOH. Okay, that means this carbon atom will be given the number 1, and if this COOH is there, then that COOHC, which it will be given the number 1. That is the meaning of this statement. Assign 1 to the functional group COOH and CHO. Accept that numbering which gives smaller number to the carbon atom carrying the functional group. This point we will see in the next clip. First you may write all this in your notebook. Now I'll explain the third point, that means how to give numbers to carbon atoms. This is an example given on page number 122. The first one, this is the structure of the structural formula of a particular compound. Now how many carbon atoms are there? There are 3 carbon atoms. They are like this. Okay, these are the 3 carbon atoms. I am not showing H. Now I will show you the functional group. The functional group is this. It is OH. Okay, this is the functional group. It is the basic skeleton. Now how to number it? You can number it 2 ways. Okay, either it could be 1, 2, 3, or it could be this way also. It could be 1, 2, 3. This is the structure. It could be named the other way also, 1, 2, 3. You may see whether it is from the left to right or from right to left, OH is on the second carbon atom. Okay, so how many carbon atoms are there? It is 3. So the parent alkane is propane. Okay, the parent alkane is propane. Now in the second step you have to add the suffix. What will be the suffix? The suffix is OL. I have to remove this and I have to write OL. But this OL is on which carbon atom? It is on second carbon atom. So the name becomes propan-2-ol. Okay. Now that means you may number it from left to right or right to left. But the carbon atom having the functional group should be having the smaller number. Now we will come to that on this. Now in this case you may see there are 5 carbon atoms. So 1, 2, 3, 4, 5. These are the 5 carbon atoms and the functional group is on this carbon atoms. Now I can number it either from left to right or right to left. 1, 2, 3, 4, 5. Okay, I have numbered it this way. Now I will number it from right to left. This is the basic skeleton. Okay, and this is the basic skeleton structure. Now I am going to number it from right to left. That means 1, 2, 3, 4, 5. Okay, consider I am numbering it this way. Now if I am numbering it from left to right, then chlorine is present on the 4th carbon atom, and if I am numbering it from right to left, then chlorine is on the 2nd carbon atom. Now what was the point? You have to accept the numbering which is having a smaller number to the carbon atom which is having the functional group. Okay, so the carbon atom which is having the functional group should have a smaller number. Okay, that is the rule. So how will I name this? How many carbon atoms? Carbon atoms are 5. So it is pentane. Okay, it is pentane. Now, the functional group is halogen. It is chloro. It has to be added as prefix. Okay, it has to be added as prefix. So I will put the prefix chloro. Chloropentane. Now chloro is on which carbon atom? Chloro is on 2nd carbon atom. I will select this. Why I selected this? Because that is the rule. Okay, so the name will be 2-chloropentane. You have to put a dash, 2-chloropentane. Now the next one, CH3, C double bond O, CH2, CH2, CH3. Now first I will draw the basic skeleton. 1, 2, 3, 4, 5. Okay, there are 5 carbon atoms and the double bond O is on this carbon atom. How many carbon atoms? 5. So the basic name is pentane. Okay. The basic name is pentane. Now I will number it. It can be numbered 2 ways. I will draw first C, C double bond O, C, C, C. If I number from left to right, 1, 2, 3, 4, 5. Right to left, 1, 2, 3, 4, 5. Okay, now you may see which is having which of the options is having the smaller number. This is having the smaller number, so I will select that. Okay, so you have to select the carbon atom with smaller number. So this is 2. So you have to put the 2 here and dash here. Now it is having functional group ketone. So I have to remove this E and put ONE. So this will be 2-pentanone. Okay, this will be 2-pentanone. Now the next is the same one. I will show you it in another way. This is CH3, CH2, CH2, C double bond O, CH3. Okay, CH3. Now you may see this is the structure, but the double bond is here. The double bond O is here. Now what will be the basic structure? The basic structure will be C, 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 C. This is having the double bond. Okay. Now I can number from 1, 2, 3, 4, 5. Okay, number from left to right or from right to left. If I number this way, 1, 2, 3, 4, 5. Now you may see when I am going from left to right, this is having the number 4. When I am coming from right to left, it is having the number 2. Which one will I take? I will take the number 2. So what will be the name? The name will be 2-pentanone. Okay, so whether it is here or it is here, the name will be 2-pentanone. Now I will put the C double bond O in the middle. Okay, if it is like this, CH3, CH2, C double bond O, CH2, CH3. Consider this is the structure. In this case, C, 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 C. This is the structure. This is the double bond. Now I am going to number them left to right. 1, 2, 3, 4, 5. If I come from right to left, it will be 1, 2, 3, 4, 5. Now what will be the name? The number of carbon atom is 5. So it will be pentan or pentane I will write. What is the functional group? Ketone. So I have to put the suffix ONE. I will remove E and put ONE. Okay. And ONE is on which carbon atom? It is on third carbon atom. So it will be 3-pentanone. Okay. So what are the steps while giving the names? First of all, you have to you have to count the number of carbon atoms. You have to write the name of the parent alkane. If there is CC double bond, then put ENE. If there is CC triple bond, put YNE. The next step is to see the functional group, what the functional group is there, and according to the functional group, you have to remove the E. Okay, E. In these cases, I have removed the E and put the suffix. If it is a prefix, you may write it this way. The third point is you have to assign numbers to the carbon atoms. You have to see to it that the carbon atom with the functional group is having a smaller number. So these are the steps which are to be followed while giving IUPAC names. Now we will see the next. Now the next is the complete the table question. On page number 122, you have been given the common names of some compounds and the condensed structural formula. You have to write the IUPAC names for the same. Okay, I have written the common names. You may see the first one is ethylene. It is having 2 carbon atoms. Okay, it is having 2 carbon atoms. That means the parent alkane is ethane. But as it is having a carbon-carbon double bond, its name will be ethene. Okay, its name will be ethene. Now the next, acetylene. It is having 2 carbon atoms and a triple bond. So its name will be ethyne. Its name will be ethyne. Now here, the next one is acetic acid. The number of carbon atoms in this case is 2. And what is the functional group? The functional group is COOH. So what will be the suffix? The suffix will be oic acid. What is the number of carbon atoms? 2. So the parent alkane is ethane. Okay, the parent alkane is ethane. The functional group is carboxylic acid. Okay, that is oic acid. That means I will remove E and put oic acid. That means the name is ethanoic acid. The next is CH3OH. 1 carbon atom. So the parent atom is methane. Okay, what is the functional group? OH. Alcohol. Suffix OL. I will remove E and put OL. That is the name methanol. Next, CH3CH2OH. How many carbon atoms? 2. That means the parent alkane is ethane. The functional group is OH. The suffix is OL. So I will remove E and put OL. That is ethanol. Next is CH3CHO. How many carbon atoms? 2. So I will write ethane. Okay, it will be ethane. And what is the functional group? CHO. That is aldehyde. The suffix is AL. So I will remove E and put AL. That is ethanol. Now the next CH3, C double bond O, CH2, CH3. Now here, how many carbon atoms? 4. So it is butane. Okay, it is butane. And which functional group? Ketone. Okay, so what is the suffix? Suffix is ONE. So I will remove E and put ONE. But you have to give the number to which the functional group is present, the carbon atom to which the functional group is present. Now here, if I number it from here, 1, 2, 3, 4, on which carbon atom is the functional group present? It is second carbon atom. If I had numbered it from here, then it would have been the third carbon atom. So 2 is less than 3. So we have to number it from left to right, and this will be 2-butanol. Okay, that means ONE group on second carbon atom. Next is CH3, CH2, NH2. What is the number of carbon atom? It is 2. So it is ethane. Okay, and which is the functional group? Amine. What is the suffix? Amine. So I will remove this E and write amine. So the name will be ethanamine. Okay, now the next is CH3, CH2, CH2, Cl. There are 3 carbon atoms, so it will be propane. Okay, it will be propane. And what is the functional group? Cl. It will be a prefix, so it will be chloropropane. Okay, and chloro is present on which carbon atom? First carbon atom. Okay, I cannot take it from left side. If I had taken it this way, okay, it will be 3, and if I take it this way, it will be 1. So I'll take 1. Why? Because it is a smaller number. So the name will be 1-chloropropane. So these are the IUPAC names. Now we'll see the common names. This is ethylene, this is acetylene, this is acetic acid. These are all objective questions. The common name of this, or the common name of ethanoic acid is methyl alcohol or methanol, ethyl alcohol or ethanol, acetaldehyde or ethanal. Okay, ethyl methyl ketone. Okay, ketone is the functional group. I will show you why it is ethyl methyl. Okay, this is the functional group, that is why it is a ketone. There are 2 carbon atoms on right hand side. Okay, so it is considered to be an ethyl group. Okay, 2 carbon atoms, and 1 carbon atom on one side, so it is considered to be a methyl group. So the name ethyl methyl ketone. Ethylamine. Okay, ethylamine because it is having 2 carbon atoms. N-propyl chloride. N means it is on the first carbon atom. Propyl, that means it is having 3 carbon atoms. Chloride because it is having the functional group chlorine. Okay, so this is about the IUPAC names, about the compounds given in the table 9.21. Now we'll see the next. Now the next is the use your brain power question on page number 121. The third question which we had discussed about: draw all the possible structural formulae having molecular formula C6H14. Give names to all the isomers. Okay, so these are the isomers of hexane. Hexane is having 6 carbon atoms, and according to the general formula CnH2n plus 2, its molecular formula is C6H14. The first one is N-hexane, the normal hexane, the straight chain hexane. Okay, it is CH3, CH2, 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 CH3. This is the normal hexane. Now we will see these are all isostructures, that means the branched structures. The first one is 2-methyl pentane. Now you may write in your textbook that CH3 is considered to be a methyl group. Methyl group if it is written as a branch, and CH3 CH2 is considered to be an ethyl group if it is considered to be a branch, if it in the structure, if it is a branch. So here you may see this CH3 is a branch, this is the straight chain, and 1C it is a branch. Okay, here you may see. So the name is, as it is on the second carbon atom, can I number from here to here? No, because I have to take the smaller number. So 2-methyl CH3 group is taken as methyl. So it is 2-methyl. What are the number of carbon atoms left? The number of carbon atoms left is 5. So the name is 2-methyl pentane. The next is the CH3 group is on the third carbon atom. So the name 3-methyl pentane. Now here you may see the methyl group is on the second carbon atom also and the third carbon atom also. I can number it from the other side also because it is the same. 2,3 dimethyl butane. The number of carbon atom left is 1, 2, 3, 4. So it is 4 carbon atom. It is butane, and methyl group on second carbon atom also and on third carbon atom also. That is why it is dimethyl. Similarly, the methyl group is on the second carbon atom in both directions. So the name becomes 2,2-dimethyl butane. So these are the isomers of hexane. Now you must have understood the importance of IUPAC naming. In IUPAC naming, you give particular names and particular positions on which the functional group is present. So from an IUPAC name, you can understand which functional group is present, okay, and it is on which carbon atom. So this is about IUPAC naming. The most important questions which are generally asked are from the table on page number 123. Okay, the table, page number 123, and the exercise questions. You may refer to the exercise today itself and study how to write the IUPAC names. If you are having any doubts, you may ask. Thank you.